Earlier I have started well foundations, caisson foundations, and different types of caisson foundation I have discussed: box caisson, open caisson, pneumatic caissons. Then what is the advantage of well foundation as compared to regular foundations? Then shape of the wells, there are different shape of the well adopted, and for each shape different conditions. First one is your circular, second one is your double D well, third one is your double octagonal well, fourth one is your twin circular, then fifth one is your rectangular well. Then I discuss about the different component: cutting edge, well curve, well staining, bottom plug and top plug. Let us start with this. Let us start with this different component. First one is your cutting edge. If I start with this cutting edge, this is your sharp edge. This is your anchor, and there is outer face. This part is your outer face. In cutting edge, there is one part is your, first part is your sharp angle. It has a sharp angle to cut soil. It should be strong that it should be strong enough so that it doesn't bend. Then second part is your well curve. If you look at this is your well curve, it is made up of your reinforced concrete. Then during sinking operation, the curve cut the soil. Then third part is your well staining. Thickness, first condition is your thickness should be adequate. Design of staining reinforcement depends upon the skin friction. Design depends upon the skin friction and unit weight of soil. Then about 75% of total reinforcement main reinforcement, 75% of total reinforcement is main reinforcement. The next part is your bottom plug. It should be strong enough to transmit the load to soil below. Then bottom plug is given a shape of like electric bulb. Its shape is electric bulb. To produce arch action, so that it reduce hoop tension. It is constructed 1:2:4 cement concrete. Then well cap. Well cap designed as a slab resting on the well. Designed as a slab resting on the well. Second part is your, it may be extended as cantilever. To accommodate piers of slightly larger size, slightly larger size, minimum reinforcement is equal to 80 kg per cm cube. Then is your top plug. Its function is to transmit load of the pier to the well staining. Then sand filling. Main purpose of your sand filling to provide stability of the well by increasing its weight. And to reduce the tensile stress. This is all about a brief discussion about the different cross sectional part, what I have made it here: cutting edge, well curve, well staining, bottom plug, top plug, a brief description about this. Then let me start with your depth of the well foundation. Depth of well foundation. What should be the depth of the foundation you will take it? So, there are different design requirement as well as different thumb rule. So, well should sunk below the maximum scour level so that sufficient, so that resistance from the sides is able to resist, so that able to resist the lateral forces. Second part is your depth of the bottom of the well below the maximum scour level is called depth of the bottom of the well below the maximum scour level is known as grip length. Then depth of foundation is chosen considering grip length and bearing capacity of the foundation. Depth is chosen, first one is your considering grip length, second one is your bearing capacity of the soil. Normal depth of scour is determined by Lacy's formula. Lacy's formula RL is equal to 1.35 into Q square by F to the power 1/3. So, RL is your, what is your RL? RL is your normal scour depth measured below the floor level Q is equal to discharge, Q is equal to discharge in cubic meter, F is equal to Lacy's silt factor, which is equal to 1.76 root over of dm. dm is equal to mean size particle. So, maximum depth of this cover is equal to 2 times R into L. So, how do you find it out? Scour level. How do you find it out your scour level? Scour level is equal to highest flood level minus R or highest flood level minus 2 RL. So, the grip length is taken as grip length is taken as 1/3 R below the scour level or 1/3 R below the highest flood level. So, what are the code provisions? From code, the minimum depth of amendment below the scour level should not be less than 2 meter for piers, abutment with arches. From code, minimum depth of embedment below the scour level should not less than 2.0 meter for piers and abutments with arches. Then it should be 1.2 meter for piers and abutments supporting other types of superstructure. According to Terjaghi and Pegg, ultimate bearing capacity you can find it out. Qu is equal to Qp plus 2 pi R Fs into df. So, I can write it Qp is equal to pi R square into 1.2 CNC plus gamma df NQ plus 0.6 R capital R N gamma NC NQ N gamma, which is equal to bearing capacity factors. R is radius of well. df is depth of well. Fs is average skin friction. Terjaghi and Pegg given a bearing capacity of a well foundation which is equal to Qp plus 2 pi R Fs df. Qp point resistance is pi R square into 1.2 CNC plus gamma df NQ plus 0.6 R capital R N gamma. Then NC, NQ and N gamma is your bearing capacity factor, R is equal to radius of well, df is your depth of well, F is equal to average skin frictions. Then let us start with these forces acting on the well foundations. What are the different forces acting on well foundation? So, first one is your say dead load, it is obvious. Second one is your live load. Third one is your impact load. In impact load, particularly bridges, means impact load affect due to your live load. It is due to live load. Sometimes it has been ignored. Then fourth is your wind load. Then fifth is your water pressure. So, intensity of water pressure is P is equal to K V square. P is your intensity of pressure, which is equal to kilonewton per meter square. K is a constant depending the shape of the well. And its value is maximum of 0.788 for square ended pier and minimum 0.237. V is equal to velocity of current. It is assumed that V square is maximum at free surface. And 0 at the deepest scour level, and 0 at scour level. Then sixth is your longitudinal forces. Sixth is your longitudinal forces. It occurs due to tractive and braking forces. Seventh is your centrifugal forces. Centrifugal forces will come if bridge is curved shape. Then last one is your buoyant force. Buoyant force reduces the effective weight of the soil. It reduces effective weight of soil. Then earth pressure. It has been calculated based on your Rankine's theory. Then seismic forces. So, if you look at what are the different forces acting on well foundation, dead load, live load, impact load is due to live load, wind load, water pressure how you can calculate P is equal to K V square, then longitudinal forces, centrifugal forces if your bridge is curved shape, buoyant forces it reduces your effective unit weight of soil, earth pressure and seismic forces. So, I will stop it here. So, next class I will start your stability analysis of wells for rigid as well as flexible wells, then we will solve few problems, then we will go for this how this sinking operation has been made. Thank you.